Hello students, welcome to Sri Jayendra's Ring Zone classes. I'm your friend and mentor for coming classes with respect to physics. This is lecture number 3 of a unit system of particles and rotational motion. So let's begin with today's class. In today's class we are going to discuss about the motion of center of mass. This is actually the part 2 of a motion of center of mass. In the previous class we were discussing that a position vector of center of mass for an n particles could be written as RCM is equals to m1r1 plus m2r2 plus m3r3 up to mnrn divide by m1 plus m2 plus m3 up to mn. If we differentiate this position vector with respect to time, it would be the VCM, that is equals to d by dt of RCM. That could be written as m1v1 plus m2v2 plus m3v3 up to mnvn divide by m1 plus m2 plus m3 up to mn. Again, if we differentiate this, that will be the ACM, it's a acceleration of center of mass, that is equals to d by dt of VCM. That could be written as m1a1 plus m2a2 plus m3a3 up to mnan divide by m1 plus m2 plus m3 up to mn. So we have discussed this previously. Even we have done the numericals based on this. While we have done the numericals, we were focusing that this is the vector quantities, and while they are the vector quantities, those they must have all those respect which any vector is required. Yes, while I'm saying this I mean while I'm saying this I mean this is I'm talking about the directions, because we always remember to have the magnitude by m1 v1 plus m2 v2 up to mn vn and divide by total mass m, but we forget to write it out with respect to direction. That's why we commit the mistake. Please don't do it. Even we have discussed this in the last class. Even we are going to have the same situation in this class too. I hope this is clear. Yes. So now in today's class we are going to move to the further in the motion of the center of mass. So first let's check it out, that we are going to discuss about the conservation of linear momentum and of center of mass. I'm talking about the center of mass. So first, what is linear momentum of center of mass? We have derived it in the previous class. That would be the P is equals to m into V. That we understand. Now we are going to talk this about with respect to or with reference to the center of mass. So PCM, it's a momentum of center of mass, is equals to m into VCM. If I differentiate this with respect to time, it's a d by dt of PCM. That could be written as m into d by dt of VCM. So this dp by dt that we call as an f, but I'm talking about the external, it's an f external, that should be is equals to mass into acceleration of center of mass. I say if no external force acts on the system, then f external would be equals to 0. And if f external is equals to 0, then PCM should be equals to constant. That means velocity of center of mass should be constant. I hope this is clear. It means the velocity of center of mass remains constant if no external force acts on the system, and this is the law of conservation of linear momentum. That means if you want to change the velocity of center of mass, you must apply external force on it. Otherwise, there would be no change in the velocity of center of mass. Does it clear? Does it? Great. So let's look at the certain examples based on this. If we see this, that two balls are there and which are going to be thrown simultaneously in air, the acceleration of the center of mass of those two balls in air is equals to g. It is something like this, that this is first ball thrown in this direction, this is another ball thrown in this direction, then the ACM will be equals to g only. One more case, when two spheres collides, the forces acting on it are internal, and so velocity of center of mass does not changes. Yes, this is the same case of collision of two bodies. When we collide two bodies, we consider them that their collision is due to internal forces because we consider them as a complete system. And if only internal forces are acting, no external forces acting, no external forces acting, that means velocity of center of mass does not changes. Yes. So if you want to look at this, look at this, it's a in one dimensional collision between two spheres. What I can have is the m1u1 plus m2u2 is equals to m1v1 plus m2v2. Yes, if I divide this both the relations by m1 plus m2, then this is the UCM. It's a before collisions center velocity of center of mass, and this is velocity of center of mass after collision. These two are the equal. If velocities are equal, I must say P initial of center of mass should be equals to P final of center of mass, which means that momentum is conserved, and when momentum is conserved, that means no external force is acting. Does it clear? Yes, can you connect every dot? Are you? Are you sure? Correct. Now, now, it's a freely falling body explodes during its fall. So, whatever the fragments are there, whatever the fragments of that freely falling body there, they may fly off randomly, but the center of mass of the system moves along the same vertical line along which that body would have traveled. Yes. So the situation would be something like this. Let's suppose this is the object and we have dropped it from here. Now it is in motion, something like this, and it has been blasted over here. Yes. And when it has been exploded or when it has been blasted, let's suppose it has been divided into two segments, two fragments, I mean. One may be moving over here, one may be moving over here. So it is quite possible that one of the body will be dropped here, one of the body will be dropped here, but the center of mass will continue. This is the center of mass. Yes, center of mass continue to be in its own vertical path, even though body has been exploded. I hope you got my point. Yes. Yes, are you clear? Are you? Great. So let's look at certain questions. It says that the velocity of center of mass of an isolated system. Well, I say isolated system, that means no external forces acting on it. Of an isolated system remains blank as long as no external force acts on the system. Yes, it is going to be constant. There is no change in the velocity of center of mass. Next, it says the acceleration of an isolated system of center of mass is 0. Yes, because we say that F external is equals to m into ACM, but in this case F external is equals to 0. So this is m into ACM. Mass could not be 0, that's why ACM must be 0. Got this? Great. Do you have any doubts up till now? Is there anything? Is there anything? Are you sure? Great. Now let's move to the laws of motion of center of mass. Let's begin with the laws, that which laws that we can even follow to the center of mass. So it's the laws of motion of center of mass. We can say that the center of mass of a system of particles moves as through total mass of the system is concentrated at a point and external forces are applied at that point only. So we can assume the total body, we can assume that total body can be replaced by a single, can be replaced by a single particle. And when we replace this total body by a single particle, we assume that the total amount of force is acting on this point only, and this point is going to move, this point is going to move such as the total body is moving. So that point will be the center of mass of the system. Next, the motion of the center of mass of the body is called as the translational motion of the body, and the internal forces will not affect the motion of the center of mass, because if F external is 0, that means VCM will be equals to the UCM. That means final velocity of center of mass will be equals to the initial velocity of center of mass if no internal forces are acting on the system. Got this? Great. One more thing. If no external force acts on a system, the acceleration of the center of mass is 0. And while I say acceleration of the center of mass is 0, the velocity and momentum of the center of mass remains constant. One more thing. Though velocity and momentum of individual particles can be vary, I am talking about the velocity of center of mass. Yes, so no external force, that means no acceleration. No acceleration, that means velocity and center of mass would remain the constant. Yes, one more thing. The motion of the center of mass can be studied using Newton's laws of motion. So you can apply all the rules and all the laws, whatever we have applied in the NLM. It's a Newton's laws of motion to the center of mass as well. It is nothing other than this. Yes, it is going to follow and it is going to observe the same amount of forces. One more very very important conclusion from this is that if no external force is acting on the system, if no external force is acting on the system, then VCM remains the constant. Its a velocity of center of mass remains the constant. We understood up till now that ACM would be definitely 0. So one more thing very important is that center of mass will not change its position due to only internal forces. Yes, so when no external force is acting, we understood that VCM that will remains constant, ACM that will be equals to 0. And one more thing is that center of mass is not going to change its position if only internal forces are acting. And if this is the case, if this is the case, that means you can write like this: it's an m1 x1, or I should rather say it's an m1 delta x1. It's an m1 delta x1 plus m2 delta x2 plus m3 delta x3 up to mn delta xn equals to 0. This is the formula that we are looking for. This could be written and this is applicable if no external forces is acting on the system. So if no external forces are acting on the system and only internal forces are acting on the system, we can write this, and this formula has much wider applications than you can thought at this point of time. I hope this is clear. Yes, so this all are the conclusions of motion of the center of mass if it has been applied by internal or external forces. Did you get this? Are you sure? Are you sure? Any doubts up till now? Is there anything? Is there? Is there anything? No? Great. Let's have look at the questions. It says that the motion of the center of mass can be studied using that motion of the center of mass, Galilean, Kepler, Newton's law. No, it's a Newton's laws of motion that we understood. Next, two balls are thrown simultaneously in air. The acceleration of the center of mass of the two balls in air is equals to. Let's look at this. This can be proved even like this. That this has been thrown in upward direction with speed. Let's say u1. This has been thrown in air with certain speed u2. While you are writing ACM, while you are writing ACM, it's an m1 a1 plus m2 a2 divided by m1 plus m2. Acceleration of this is in the downward direction, so that should be written as minus g. So this is m1 into minus of g, j cap, plus, because I have written minus g, it could be written as j, plus m2 minus of g into j cap divided by m1 plus m2. That should be is equals to 2m. That should be written as, let's say, if m1 equals to m2 is equals to m, yes, minus of 2mg j cap divided by 2m. This has gone and this is equals to minus of g into j cap. Yes, minus because downward direction is considered as a positive. Downward direction is considered as a positive, but both are in negative y direction. Yes, so acceleration of the center of mass could be written as like this. I hope this is clear. Is it clear? Is it? Are you sure? Can you do this? Can you do this? Are you sure? Great. So let's look at the certain questions based on the same concept that we have discussed over this time. Let's begin then. Suppose the question says that a bomb of mass m is projected with velocity u while making an angle theta, with horizontal. If bomb exploded at maximum height and it has been divided into two fragments, we can say one fragment came to rest. One fragment came to rest at the same time of explosion. At a same time of explosion. Find out. Find out position of second fragment. This is the question. Go through this very carefully. What does it says? Go through this very carefully. What does it say? It says that a bomb of mass m is projected with velocity u while making an angle theta with the horizontal. And if we understand that if bomb is exploded at maximum height, if bomb is exploded at maximum height and it has been divided into two fragments, one fragment come to rest at the same time of explosion, find out the position of the second fragment. So the situation is looking something like this, that this was the, let's say, y, this was the x, a bomb has been projected something like this. This is the velocity u while making an angle theta. It is going to be exploded over here. Yes. So when it has been divided into two fragments, one of the fragments, let's say write it as an m1, came to rest in at that moment only. While it is come to rest, it is the free fall of this particle. So m1 would be here. While I say here, it would be the half of the range. That you understand that h max is from the x displacement, it is the r by 2. And I'm looking forward, for the mass of position of mass 2. Let's say it may be over here. Yes. So what I understand is that no external force is acting on the system. In this situation, no external force is acting on the system. And so if no external force is acting on the system, if no external force is acting on the system, that means position of COM, it's a position of center of mass, will be the same. It means center of mass will be at range. We could see this is at, yes. So if this is the case, if no explosion were there, let's suppose that bomb has been thrown and it is not going to be exploded, then what would be the trajectory, or what would be the path of this bomb? Then it would be moving like this, and it is going to deliver over here. So this would be the position of center of mass if it has not been exploded. Now it is the same case. It is the same case that even though it has been exploded, but the explosion doesn't require any external force, or only internal forces are acting. That means position of center of mass is not going to be changed. And if position of center of mass is not going to be changed, that means center of mass of the body will be at location R. It is at the range. So now what can I do is that I can write like this. It's an xcm would be equals to m1 x1 plus m2 x2 divided by m1 plus m2. My xcm will be at range. This is m1 into x1 plus m2 into x2 divided by m1 plus m2, while x1, look at this, this is at half of the range. From this position, this is at half of the range. So x1 could be written as m1 into r by 2 plus m2 x2 divided by m1 plus m2. This is equals to range. So this could be written as m1r plus m2r. This is equals to m1r by 2 plus m2x2. And if I try to solve this, it's an m1r minus m1r by 2 plus m2r whole divide by m2. This will be the x2. So x2 could be written as m1r minus m1r by 2. It's an m1r by 2 plus m2r divided by m2. This would be the final answer. I hope this is clear. What was your answer? What was your answer? Was it same? Was it same? Are you sure? Are you sure? Was it same? Are you? Great. So can you do this? Can you do this? Shall I change something? Shall I? Let's have a look. that in the previous question, if bomb exploded into three fragments, first M1 will be at rest instantaneously, or I should say at that instant. M1 will be at rest at the instant of explosion. Second, M2 will retrace its path. Then third, find position of M3. Yes, this was the situation. This is y. This is x. It is going to something like this. This is velocity u while making an angle theta. At this position, it is going to be exploded, and if it is going to be exploded over here, one of the object came to rest momentarily at same moment, so it has been reached to here m1. M2 M2 would be retrace its path, so M2 would be here. We don't know where M3 will be, but let's assume that it would be at here somewhere. Yes, it is not the center of mass, it is just any random location. Let me correct it. Maybe somewhere here. You are looking for the M3 X3, that means you are looking for the X3. What I can do, what can be done? What I understood is that XCM could be written as M1 X1 plus M2 X2 plus M3 X3 divide by M1 plus M2 plus M3. Yes, this XCM should be equals to R. Now we understand that this has been explosion, and explosion has been created due to internal forces and no external forces are acting on the system. So if no external forces are acting on the system, no external forces are acting on the system, that means that center of mass is not going to change its position, and if it is the case, then XCM will be at position R only. M1 into X1, it's an R by 2, half of the range, plus M2 into, it has retraced its path, so from the origin, from this location, it would be at 0. M3 X3, that is what I am looking for, and let's suppose the total mass is the capital M. I hope this is clear. So let's just try to solve this. It's an M into R, that would be equals to M1 into R by 2 plus M3 X3. So this M3 X3 could be written as M into R minus M1 into R by 2. If you wish, you can write this as an M1R minus M1 into R by 2 plus M2R plus M3R. This is M1R by 2 plus M2R plus M3R. This is M3 X3, and if you write this as an X3, this is divided by M3. I hope this is clear. So can you do this? Can you? Yes, it is much easier. It is much easier. What you need to think is that always think that which kind of forces are acting on the system. When I say which kind of, I mean whether external forces or internal forces. If external forces are acting, if external forces are acting on the system, that means there would be the change in the position of center of mass. But if only external forces, only internal forces are acting on the system, and no external forces are acting on the system, that means position of center of mass is not going to be changed. And when position of center of mass is not going to be changed, that means you can conserve the momentum, and you can always write this kind of situation. Yes, I hope this is clear. Is it clear? Is it? Great. Now let's work for the next category of questions. Let's suppose, look at this. This is a plank, or you can say this is a boat having mass m, length l. You yourself standing over here. Let's say your mass is m1. Yes. And when I say this is a boat, this is a boat, or this is plank that has been placed in the water, that means almost no friction is acting between the plank and the water bot between the plank and the water, or between the boat and the water. Yes. So the question says that what would be the displacement of boat when person reaches to other end? This is the question. Now think what you can do. This is the question. What could be done? They says that initially the person is at here. In a next At a next time instant of time, he would be like to be here. Yes, he wants to reach to the other end. So what would be the displacement of boat? So the first question is why the boat will displace. Do you have the answer of this? The first question is why the boat will displace. So what we understand is, have you remembered the cases? Have you remembered the cases of the recoiling of a gun? Yes. So the we have a gun over here, and if we fire the bullet, let's suppose this is gun. Yes, yes, yes. If we fire the bullet and the bullets are moving in this direction, then the gun will be moving in this direction. I hope this is clear. If you have ever tried the boating, yes, if you have ever tried the boating, then if you are just about to leave the boat, if then you are moving forward, but your boat is moving backward. Yes, it is the same thing. So once you want to displace in the positive x direction, so that boat is going to be there in the negative x direction. Is it clear? So this is the practical aspect. Now once we, if we want to look at this from the point of view the pure physics, or we can say pure concepts only, then think it, that which forces are acting. What, when we can say that forces between this two is that there is a force of friction, there is a force of friction between plank or between boat and man. But if I consider that this is my system and this is the boundary of my system, let's have a look. Yes, this dotted lines are the boundary of my system. So on this system, on this system, no external force is acting. So PCM, it's a momentum of center of mass, will be conserved. Yes, there may be possibility that in your mind something you are thinking that no sir, extra you have already seen the force of friction. That force of friction is acting between the man and the boat. Then how could I say that no for external force is acting? Because this frictional force between man and this boat would be considered as an internal force, because This both are, that means I mean a boat and a main both are part of my system. I hope this is clear. So momentum will be conserved, a very first thing. Next thing, position of center of mass will not be changed, will not be changes, even though person moves on the other end. So if person wants to move on the other end, a boat needs to displace in the negative x direction, so that position of center of mass is not going to be changed. I hope this is clear. This is the pure logical aspect of this concept. Yes, do you understand this? That when person is moving in the forward x direction, then boat will be shifting in negative x direction, so that position of center of mass does not changes. Even the same case is true. Even the same case is true when we fire a bullet. Bullet is moving in forward direction while the gun is moving in negative x direction. Why? Because when we fire the bullet, no external force is acting on the system of gun plus bullet. And if no external force is acting on the system of gun plus bullet, that means we can say that to conserve the momentum, or I should say this, that position of center of mass should remain at the same position. So if bullet is moving forward, then the gun must move in the backward direction. This is the same case with the boat and person. I hope this is clear. So how will you do this? This is just the logical aspect how we can do this. So what we understood is, this is boat having mass m, length l. You are standing over here, your mass is m. You are going to move in this direction, then the boat will, let's say, move in this direction. Let's suppose boat has been displaced. Let's suppose boat has been displaced by an amount x. If boat has been displaced by an amount x, then what we can see is that m1 delta x1 plus m2 delta x2 up to mn delta xn would be equals to 0. This is my master relation. Yes, because center of mass is not going to change its position. Here I have two objects, one boat, another person. So I could write like this, it's an m1 delta x1 plus m2 delta x2. That should be equals to 0. This is the person, this is the boat. So first let's talk about the boat. The boat is going to be displaced by an amount of x, but boat is going to move in negative x direction, so I should write it's a m into minus of x, that would be equals to 0. Now let's talk about the person. So when boat has been displaced, it is something like this, that this is the initial situation, and now boat is going to be displaced in this direction, that it has displaced by x. So now person needs to move by a distance of L minus x. Can you see this? Yes, a person needs to switch, or person needs to move, or person needs to displace by an amount of L minus x to reach at the other end of this boat. Does it clear? Does it does it great. So the mass of the person, it's an m into bracket L minus x, as it is moving in positive x direction, I have taken it as a positive. So let's just solve this. It's an ml minus mx, that would be equals to 0. And so if this is the case, that is ml is equals to mx plus mx. So this would be equals to m plus m into x. This is equals to ml. So this x is equals to m into l divided by m plus capital M. This is the displacement of the boat. That is x is equals to m into L divided by m plus m. I hope this is clear. Is it clear? Any doubts? Any doubts in this? Is there anything? No? So, shall we continue with this with certain modifications and certain variations? Let's check it out. Next, the question says that let's suppose this is boat having mass m, length L. Here you are standing, your mass is m1. Here your friend is standing, it's a mass of m2. So the question is, if m1 moves towards other end to meet m2, find out displacement of boat. So it says that m1 moves towards the other end to meet m2. That means indirectly they are saying that m2 is not going to move at all. Indirectly they are saying that m2 is not going to move at all. And when m1 is moving towards the other end to meet the m2, we need to find out the displacement of boat. How will I do it? What could be done? What could be done? What do you think? What could be done? So what I understood is that let's suppose the situation is that m1 is shifting towards this, while m1 is moving towards this, the boat needs to moving towards this. Why? Because momentum conservation. Yes, as person is moving in forward direction, but he can move in the forward direction due to force of friction only. But that force of friction should be treated as the only the internal forces acting between the system. No external force is acting on the system, and if no external force is acting on the system, that means person is moving in the forward direction, boat is moving in the negative x direction. So this was the situation, that it was the initial level and this is the final level. Yes, this is the displacement of boat. But 1 minute, when I say this is the displacement of the boat, then even the m2 has been displaced. Don't you think so? M1, even m1 would be here now. Yes, they are talking with each other. Yes, so this is m1, this is m2, and they are talking with each other, and boat has been displaced by x. But only not only boat has been displaced, even m2 has been displaced. Yes, please take this into consideration and have a numerical. So let's just try to do it. We can say that in this situation it's an m1 delta x1 plus m2 delta x2 plus m3 delta x3, that would be equals to 0. And while I'm saying so, that let's suppose this is the person 1, this is the person 2, this is the boat. Yes, person 1, person 2 and boat. Let's write it down, their displacement. Boat has been displaced by an x amount, so this is minus of m into x. Person 2, as boat has been displaced by x, even person 2 has been displaced by x. Please don't make a mistake over here, because as a student you understand that if boat has been displaced by x but m2 is not moving at all, so displacement of m2 is 0. No, it is not the case. Even m2 has been displaced because m2 is sitting on the boat, and when boat has been displaced, m2 definitely displaced by a same amount as a boat has been displaced. So that should be is equals to minus of m2 into x, while person m1 has displaced by an l minus x, but it is moving in the positive x direction. So I should write it, it's an m1 into bracket L minus of x. That is leads to a 0. So this could be written as m1L minus m1x. That would be equals to m2x plus mx. So this could be written as m1L is equals to m1x plus m2x plus mx. So this x should be is equals to m1L divided by m1 plus m2 plus capital M. This is the x. This is the displacement of the boat. I hope this is clear. Is it clear? You got this. Are you sure? Great. Do you have fun in this? Do you? Great. Let's think for the next question. Now let's suppose this was the boat having mass m, length L. You are standing over here. You are the person 1 m1. Here your friend is standing over here m2. Now the question is find displacement of boat if both the persons interchange their positions. So I need to find out the displacement of the boat if both this person are going to interchange their position. While I am writing this, I consider that let's suppose m1 is greater than m2. Suppose. So how will you do this? So the situation is that m1 is moving in this direction and m2 is moving in this direction, while m1 is much greater than m2. As m1 is moving in the forward direction, boat must displace in the negative x direction. So what I guess the situation would be something like this, that this is the displacement of the boat, and when it has been displaced over here a person that we call as an m2 would be there. Here the person that we call as an m1 would be there. Yes, this has been displaced by an amount of x. So how will you do this? Let's just write that we could write it's an m1 delta x1 plus m2 delta x2 plus m3 delta x3, that would be equals to 0. We can say this is the, let's say, person 1, this is person 2, while this is boat. So let's begin with the boat. It may be the easiest approach. So this is minus of m into x. Let's talk about the person 2. Yes, it has been moving in this direction, even in the negative x direction, so it is a minus of m2. But what would be its displacement? Let's look that as boat has been displaced in this direction, so the actual displacement of person 2 is L plus x. I hope you can feel this, because when and when person m1 is going to move in the positive x direction, then it needs to walk, or it needs to travel a distance of L minus x only. So this is the displacement of m1, it's an L minus only. So when this has to travel for the L minus x distance only, so it is confirmed that m2 needs to travel an x distance more than this, so it needs to travel L plus x, and this is equals to 0. I hope this is clear. So if you want to solve this, this could be written as m1L minus m1x minus m2L minus m2x equals to capital M into X. While doing this, it's an M1L minus M2L. This is equals to M1 plus M2 plus M into X. So this X could be written as M1 minus M2 into L divide by divide by this could be written as M1 plus M2 plus capital M. I hope this is clear. Does it? Does it clear? Are you sure? Yes? Great. Any doubts? Any issue over this? Is there anything? Does it clear? Do you have fun? Great. Let's look at this question. The question says that let's suppose this is a wedge having mass m, and on this wedge a block of mass m has been placed. This is the length L. This all surfaces are smooth. All the surfaces are smooth. It says that find out displacement of wedge M when block M when block M reaches to the foot of wedge. That means when it has been reaches over here, you need to find out the displacement of the wedge M. And all the surfaces are smooth. Even on this surface you can see this, that even on the surface between wedge and the ground, no friction. Even this wedge and block M having no friction. So this is the situation, and this is has been asked what is going to be done. So what I understood is that when this is moving towards this, yes, this wedge, let's suppose assume that this is the reference line and this wedge has been displaced by this, is something like this. Yes, now it is over here and this has been displaced by X. So if this is X, this needs to be L minus X. Is it clear? Is it clear that if this is X, this is L minus X? So what we can see is that as no external force is acting on the system, no external force is acting on the system, that's why X coordinate of COM is at rest. And when X coordinate of center of mass is at rest, what I can have is this is M1 delta x1 plus M2 delta x2, and that would be equals to 0. So if M1 delta x1 plus M2 delta x2 is equals to 0, that means let's assume that this is the wedge having mass m and this is the block having mass m. So this has been displaced in negative x direction. Yes, so what I can write is the minus of m into x plus m into bracket L minus x, and that would be equals to 0. So this could be written as mx is equals to m into bracket L minus x. Yes, so when I solve this, it would be an mx is equals to ml minus of mx. It would be an mx plus mx, that would be equals to ml. So from this it's an x is equals to ml divided by capital M plus small m. I hope this is clear. Is it? Are you sure? Can we do this? Can we? Is it possible? Is it possible? Are you sure? Can you do it? Are you sure? Great. So this is the displacement. This x is equals to ml divided by m plus m. I hope this is clear. Is it clear? Great. So, so do you have any doubts up till now? Do you have any doubts up till now? Anything? No? So shall we move further to the next? Let's have a look. The question says that a man of mass m1 is standing on a platform m kept on a smooth horizontal surface. If man starts moving, if man starts moving on the platform with velocity vr relative to the platform, find out recoil velocity of platform. This situation could be seen something like this, that this was the platform data is talking about. This is platform is having mass m, and let's assume that you are standing over here initially, and then if a man starts moving on the platform, but this is with velocity vr which is relative to the platform. That means a person is moving in this direction, but vr is the relative to the platform. So what I need to do, I need to find out the velocity of the platform. How will I do this? I should say this is v1. Let's say v1. Yes, it's a velocity of man. So what can I do? And how will I do this? What first thing I must understand is that absolute velocity, absolute velocity of man will be, it's a vr, it's a relative velocity minus velocity of the boat. It is vr minus v, because if you are not confirmed with this, go through the data one more time. It says if man starts moving on the platform with velocity vr which is relative to the platform, if man starts moving on the platform with velocity vr relative to the platform, it is moving with velocity vr relative to the platform. That means with respect to platform, the data is given as a vr, and vr, as person is moving in positive x direction, platform is moving in the negative x direction. So platform is having a velocity of v in the negative x direction, while person is having a velocity in the positive x direction, and the velocity of man that I have denoted as a v1, that could be written as vr minus v. I hope this is clear. Now I can say that as no external force is acting on the system, no external force is acting on the system. So initial momentum should be equals to final momentum. When I say initial momentum, it was m plus m into 0. When I say final momentum, I must say mass momentum of the person, as it is in positive x direction, it would be a vr minus of v minus of platform is having mass of capital M and it is having velocity v, but as it is moving in the negative x direction, I have written it minus. So this is capital M into V should be is equals to M1 into VR minus M1 into V. So this is M into V plus M1 into V, that is equals to M1 into VR. So this V is equals to M1 into VR divided by M plus M1. I hope this is clear. Have you got this? Are you sure? Are you sure? Do you find this interesting? Yes, very interesting. So ready for one more question? Are you ready? Can we do it? Can we? Great. Let's have a look. Let's suppose the question says that uh, let's look at the situation first. That one of the cart is there, and that that cart is having a mass of m, and let's suppose a gun has been there. Yes, and this is at a 60-degree with respect to horizontal. So the question is a gun having mass m fires a bullet with speed vr, which is relative to the barrel of the gun, relative to the barrel of the gun, which is inclined at an angle of 60-degree with horizontal. It has said that the gun is placed on a smooth surface. So find out recoil speed of the gun. So go through the data carefully, and what can we do for this? What we are supposed to do is that, as the situation is something like this, that this was from where 60-degree, and this is VR. While I say this is VR, what I can do is that when bullet is fired like this this is going to be displaced like this, and let's say it has been displaced by this in the V. So what I can have is, if I make a component of this, it's a VR cos 60, this is VR sin 60. Yes, is it clear? Is it clear? But if I say that one more velocity on the x direction would be there, if I talk about the system, this is the V. I hope this is clear. So indirectly, indirectly what I can say is indirectly what I can say is that this would be the net speed, or I could say the absolute velocity of bullet is VR sin 60 minus of V. Oh, I made a mistake. It's a VR cos 60. Sorry. In the horizontal direction, it's a VR cos 60 minus of V. And we can conserve the momentum. So what I could write is the initial momentum should be the final momentum, And if I write the initial momentum is equals to final momentum, what I could write is initially it was 0. Initially it was 0. If the velocity of the bullet has been taken as a positive, then that could be written as m into Vr cos 60 degree minus of V. But that barrel would be shifted in the negative x direction, so this is minus of m into V, that would be equals to 0. So this is m Vr cos 60 minus of m into V minus of capital M into V, that would be equals to 0. So that should be written as m into Vr into cos of 60. That would be equals to m plus m into velocity V. And this V could be written as m Vr cos 60 degree divided by capital M plus small m. This is V. I hope this is clear. Does it clear? Does it clear? Are you sure? Are you sure? Have you got this? Have you? Are you clear with this? Yes. So this was the cases when no external force is acting on the system, and we can conserve the momentum, and that momentum could be conserved. Even this could be thought on a basis of that center of mass is not going to change its position. So once one of the object is moving in, let's say, positive x direction, then the another object will try to move in the negative x direction. Yes, great. So let's have one more question. Let's have one more question. It says that, let's suppose a mm, let's take in something else. It's a flat car of mass m is at rest on frictionless surface with a child of mass m is standing on the edge of this car. So if child jumps off the child jumps off from the car towards right with an initial velocity of u with an initial velocity u with respect to car. This is with respect to car. Find out. Find velocity of car after it jumps. So what would be the situation? The situation may be something like this, that this was the car. Let's say, yes, we have a very big car. So this is the car having mass m, and here you are standing. Initially both the systems are at rest. You are standing on the edge, and let's suppose you have jumped off in this direction with a speed of u, but this u is not the absolute speed. This u is not the absolute speed. Now you understood this. This is the speed with respect to car. So what I can understood is that the absolute velocity of person, that means absolute velocity of child, that is equals to u minus of v. If I understood that this will be the moving with speed v, or this would be the recoil velocity with v. So let's do the same thing that we have done up till now, that my momentum would be conserved. That means pi is equals to pf. Initially it was 0, Let's suppose the child is moving in positive x direction. This is u minus v. Then the cart, or I could say a car is moving in the negative x direction. This could be written as minus of m into v. So this is equals to m into bracket u minus v, that is equals to m into v. So this is mu minus of mv should be equals to m into capital V. This could be written as mu is equals to capital M plus small m, that means the masses of both multiplied by velocity v, and this v could be written as m into u divided by capital M plus small m. That's it, you did it, great job. I hope this is clear. Is it clear? Is it clear? Are you sure? Are you sure? Now, shall I make certain variations in the same questions? Shall I? Let's have a look. It says that the question says that in the previous question, if car is moving with velocity v1 and child jumps off child jumps off with child jumps off in the direction of motion of car, direction of motion of car with velocity u, which with respect to car. Find out, find final velocities of child and that of car after jump. So just imagine the situation, have a rough sketch of it, and think, how will I do this? How will I do this? What can I do? So when I thought this initially, according to the me, situation is something like this, that this is the car having mass m, this is the child, and initially child was on the car and both are moving with velocity of v1. Now the situation that this is car, yes, it must be having wheels, yes, great. So the car is moving with velocity v1. Now the situation is that this was the car and this child is going to just jump off. This is person m with velocity, let's say it is going to be jump with velocity u, and this is moving. Now let's say this is velocity v2 as the speed has been changed. So what could I do, or how should I do this? First thing that I must understand is that initial momentum should be equals to final momentum. While I understand the initial momentum, this plus this as in combined body is moving in the positive x direction. So if I write the initial momentum, it is capital M plus small m. They are moving with, let's suppose, a speed of v1 should be equals to, now should be equals to, as this person is going to jump off in this direction, this person is going to be jump off in this direction, and let's suppose it is said that he jumps off in the direction of motion of the car. That means motion of the car is in this direction, even he is going to jump in this direction. So this could be written as the car is moving with speed v2 and the person is having a speed of u plus v2. Why do this? Yes, it is on the same direction. So even the whatever the person who is standing on the ground, let's suppose you are standing on the ground and you are observing this child, then you will feel that he is going to jump, or he is moving with a speed of not only u but with v2 as well. So its net speed would be equals to u plus v2. I hope this is clear. So what you need to do is that velocity, you need to find out, let's first velocity of car after jump. So velocity of car after jump, that we call as in v2, that could be written as, if I simplify this, it is just the m plus m into v1 minus of m into u, divide by capital M plus small m. And when I say velocity of the child, velocity of child after jump, that is the u plus v2. So if I simplify this, it would be m plus m into v1 plus m into u, divide by total mass of the system. This is m plus m. I hope this is clear. Is it clear? Is it? So any doubts? Anything? No? Great. Let's just wind it up this session over here. This is all about the motion of center of mass. So in a very first session we were discussing for the center of mass. It was the lecture 1 of the system of particles and rotational motion. Then in the second and third lecture we were discussing about the motion of center of mass of the system. So what you need to understand is this is all about the center of mass. That means when it is at rest, you need to find out the center of mass. When it is in moving, you need to find out its motion. So please do as many questions as possible. This is the requirement of the competitive world, that you need to practice a lot to crack it. I hope this is clear. Yes, so please do at least 80 to 90 questions of just the motion of the center of mass according to the conservation of momentum category. Please, then you will have an confidence over it. I hope this is clear. So please do it, this is a requirement. If we are supposed to do practice a lot, no one would be there to stop us to get selected. I hope this is clear. Please do it. This is the requirement. Thank you. Have a good day. Take care.